Today, though, and for this first week, week 0, so to speak, we use Scratch because, again, it will allow us to explore some of those programming fundamentals that will be in C and in Python and in JavaScript and other languages too, but in a way where we don't have to worry about the distractions of syntax. So the world of Scratch looks like this. It's a web-based or downloadable programming environment that has this layout here by default. On the left here, we'll soon see, is a palette of puzzle pieces, programming blocks that represent all of those ideas we just discussed. And by dragging and dropping these puzzle pieces or blocks over this big area and connecting them together, if it makes logical sense to do so, we'll start programming in this environment. The environment allows you to have multiple sprites, so to speak, multiple characters, things like a cat or anything else. And those sprites exist in this rectangular world up here that you can full screen to make bigger. And this here, by default, is Scratch, who can move up, down, left, right, and do many more things too. And within Scratch's world, you can think of it as perhaps a familiar coordinate system with x's and y's, which is helpful only when it comes time to position things on the screen. Right now, Scratch is at the default 0, 0, where x equals 0 and y equals 0. If you were to move the cat way up to the top, x would stay 0, y would be positive 180. If you move the cat all the way to the bottom, x would stay 0, but y would now be negative 180. And if you went left, x would become negative 240, but y would stay 0. Or to the right, x would be 240, and y would stay 0. So those numbers generally don't so much matter because you can just move relatively in this world, up, down, left, right. But when it comes time to precisely position some of these sprites or other imagery, it'll be helpful just to have that mental model of up, down, left, and right. Well, let's go ahead and make perhaps the simplest of programs here. I'm going to switch over to the same programming environment now for a tour of the left-hand side. So by default, selected here are the category in blue, motion, which has a whole bunch of puzzle pieces or blocks that relate to motion. And whereas Scratch, as a graphical language, categorizes things by the type of things that these pieces do, we'll see that throughout this whole palette, we'll have functions and variables and conditionals and Boolean expressions and more, each in a different color and shape. So for instance, moving 10 steps or turning one way or the other would be functions categorized here as things like motion. Under looks in purple, you might have speech bubbles that you can create by dragging and dropping these that might say hello or whatever for some number of seconds. Or you could switch costumes, change the cat to look like a dog or a bird or anything else in between. Sounds too, you can play sounds like meow or anything you might import or record yourself. And then there's these things Scratch calls events. And the most important of these is the first, when green flag clicked. Because if we look over to the right of Scratch's world here, this rectangular region has this green flag and red stop sign up above, one of which is for play, one of which is for stop. And so that's going to allow us to start and stop our actual programs when that green flag is initially clicked. But you can listen for other types of events. When the space bar is pressed or something else. When this sprite is clicked or something else. And here you already see a programmer's incarnation of things you and I take for granted every day now on our phones. Anytime you tap an icon or drag your finger or hit a button on the side, these are what a programmer would call events. Things that happen and are often triggered by us humans, and things that a program, be it in Scratch or Python or C or anything else, can listen for and respond to. Indeed, that's why when you tap the phone icon on your phone, the phone application starts up because someone wrote software that's listening for a finger press on that particular icon. And so Scratch has these same things too. Under control in orange, you can see that we can wait for 1 second or repeat something some number of times, 10 by default, but we can change anything in these white circles to anything else. There's another puzzle piece here, forever, which implies some kind of loop where we can do something again and again. And even though it seems a little tight, there's not much room to fit something there, Scratch is going to have these things grow and shrink however we want to fill similarly shaped pieces. And here's those conditionals. If something is true or false, then do this next thing. And that's how we can put in this little trapezoid-like shape some form of Boolean expression, a question with a yes, no, true, false, or 1, 0 answer, and decide whether to do something or not. You can combine these things too. If something is true, do this, else do this other thing. And you can even tuck one inside of the other if you want to ask 3 or 4 or more questions. Sensing too is going to be a thing. You can ask questions, aka Boolean expressions like, is the sprite touching the mouse pointer, the arrow on the screen, so that you can start to interact with these programs? What is the distance between a sprite and a mouse pointer? You can do simple calculations just to figure out maybe if the enemy is getting close to the cat. Under operators, some lower level stuff like math, but also the ability to pick random numbers, which for a game is great, because then you can kind of vary the difficulty or what's happening in a game without the same game playing the same way every time. And you can combine ideas. Something and something must be true in order to make that kind of decision as before. Or we can even join two words together. It says apple and banana by default, but you can type in or drag and drop whatever you want there to combine multiple words into full, larger sentences. And then lastly down here, there's, in orange, things called variables. In math, we've obviously got x and y and whatnot. In programming, we'll have the same ability to sort of store in these named symbols, x or y, of values that we care about, numbers or letters or words or colors or anything ultimately. But in programming, you'll see that it's much more conventional not to just use simple letters like x and y and z, but to actually give variables full words or singular or plural words to describe what they are. And then lastly, if this isn't enough colors blocks for you, you can create your own blocks. And indeed, this is going to be a programming principle we'll apply today and with the first problem set, whereby once you start to assemble these puzzle pieces and you realize, oh, would have been nice if those several pieces could have just been replaced by one had MIT thought to give me that one puzzle piece, you yourself can make your own blocks by connecting these all together, giving them a name, and boom, a new puzzle piece will exist.